What if we mix together ionic and covalent compounds? Then we're going to have to be able to name them or write the formula, be able to determine what type of bond it is so we know what set of rules to use. So I've created this very complicated chart to help us be able to do that. So stick with me on the chart. It's not that bad. All right, so to identify the type of bond, you've either got two choices. It's either ionic or covalent. All right, just as a review, remember in ionic compounds, electrons are transferred, and in covalent, they are shared. All right, so the transferred part is the key for ionic. You've got to have a cation and an anion. That is how you identify an ionic compound. Another easy way of doing it is you're going to have a metal and a non-metal most of the time. Or you could also look for polyatomic ions. If you see a polyatomic ion, you know it's ionic. If you see a metal and it's a transition metal, you know it's ionic. Because remember, anytime you see a metal, it's going to be ionic. So those are some ways that you can identify easily if it's ionic. If it's covalent, here is your key. I'm going to put it in a big, nice bubble. You're always going to have nonmetals. Ionic, we have a lot of possibilities, but for covalent, it's always going to be nonmetals, no matter what. You'll also see prefixes. We never use prefixes for ionic, so if we see a prefix, it's going to be covalent. So let's take a look at a few examples and see if we can determine if they're ionic or covalent. I've left the chart there so that way we can use that as a guide. All right, lithium nitride. So I need you to grab your periodic table and I need you to look for these elements. I need you to look for lithium and I need you to look for nitrogen. All right, what do you see? Well, one thing that I noticed about lithium is that it is a metal. So if lithium is a metal, then if I look at my list of the two types of possibilities, I can tell, boom, if it's a metal, it's going to be ionic. Nitrogen is also a non-metal, but the fact that lithium is a metal, it's automatically ionic. All right, let's go ahead and look at the next example. Carbon tetrachloride. All right, I see a couple of things that are a little intriguing. So the first thing I want you to do, though, is to look up the elements on the periodic table. You got carbon, and we've got chlorine. All right, so where are they on the periodic table? They are to the right of the zigzag line. Remember, elements that are to the right of the zigzag line on the periodic table are nonmetals. So because I have a nonmetal with another nonmetal, I know immediately that they're going to be covalent. But there's another way that we can tell that this is covalent, and that is the prefix. So remember, in covalent compounds, we have prefixes. And so because I see a prefix, I know that it's going to be covalent. So our final answer is that this is going to be covalent. All right, let's go to the next compound, lead 2 nitrate. All right, we need to look up this element on the periodic table. Lead is a metal. And there's something else I see. I see a Roman numeral. So remember that if you have a metal, that it's automatically going to be ionic. The other indicator is that the Roman numeral is normally for a transition metal, but remember that tin and lead are not transition metals, but we still need to use a Roman numeral. Either way, it's ionic. Now, the other thing that you'll probably notice is nitrate. One of the interesting things about nitrate is that it's a polyatomic ion. That's another indicator that this is ionic. Anytime you see a polyatomic ion in a cation-anion relationship, it's going to be ionic. So our final answer is that this compound has an ionic bond. Mn2O3. Again, I'm going to ask you to look these elements on the periodic table. All right, we see manganese. Manganese is a metal. Specifically, it's a transition metal. Oxygen is a nonmetal. So once again, we have this metal-nonmetal relationship. So the final answer here is that this is going to be ionic. If we named this, we would need a Roman numeral for the metal because it's a transition metal. All right, P2O5. Look the elements up on the periodic table. So I'm going to look for phosphorus. On the periodic table, it is a non-metal. All right, let's go ahead and take a look at the next one. Oxygen. It's also a non-metal. All right, what type of bond is it when you have nonmetals together? It's going to be covalent. So when I have two nonmetals together, it's automatically going to be covalent. All right, let's take a look at this one. I'm going to ask you to look up the elements on the periodic table. All right, so we got calcium. What type of element is calcium? Calcium's to the left of the zigzag line, so it's a metal. Immediately, you know it's ionic. Or you could look at this guy right here. That's nitrate. Nitrate is on our list of polyatomic ions. So because nitrate is on our list of polyatomic ions, we automatically know that it's going to be ionic. All right, let's take a look at another example. Potassium sulfate, same deal. Let's find them on the periodic table. All right, potassium, it is a metal. Sulfate is on our list of polyatomic ions. So because this is on our list of polyatomic ions, those are in it, that we have potassium, a metal, it's immediately, we know, going to be ionic. All right, they get trickier. SiO2. Some people get really freaked out about silicon. It's really close to the zigzag line, but if you look at its position, it is definitely to the right of the zigzag line. So we treat silicon as if it were a nonmetal in terms of its naming system. So because of that, we're going to treat it as a nonmetal because it's to the right of the zigzag line. So because of that, we're going to say that this is going to be, for our IUPAC naming purposes, a nonmetal. All right, let's take a look at next one, oxygen. Oxygen's definitely going to be a nonmetal. All right, the other easier way you could do it, instead of worried about silicon, anytime you see silicon or carbon, it's automatically going to be a covalent bond. Silicon and carbon are always going to share their electrons. So because they're going to share their valence electrons, it's going to be covalent. So anytime you see carbon or silicon, it's going to be covalent. So that's kind of an interesting thing to look at. All right, let's look at this one, NO3. Some people are like, what? I've got nitrogen and oxygen immediately. That's going to be a nonmetal with another nonmetal. I know that specifically nonmetals together are going to be covalent, and they're like immediately covalent. But some of my students who think a little bit more look at their list of polyatomic ions and they see, oh, well, what about this? NO3 minus 1. That's on my list of polyatomic ions is nitrate. But this is not nitrate. All right, the difference is that nitrate has a charge. Its charge is -1. Does this guy have a charge? Nope, there is no charge. If no charge is there, it's not because they made a mistake. It just literally has no charge. It's neutral. So if you have a charge then on NO3 that's -1, then sure, it's nitrate. But there's no charge here. So because there's no charge, this is not nitrate. This is nitrogen trioxide. So because of that, it is covalent. This one, people are like, all of these are nonmetals. Nonmetal, 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 nonmetal. It's all nonmetals. Surely it must be covalent. No, let's take a look. So this is a polyatomic ion. This is a polyatomic ion. This is going to be ammonium hydroxide. So why is this ionic if it is made of all nonmetals? Well, the reason is because truly, by definition, ionic compound is defined as a cation plus an anion. It doesn't matter what the cation and anion are. In this situation, we have a polyatomic ion plus another polyatomic ion. So you can have two polyatomic ions together if it's a cation and anion, which this situation it is. So this is an example of an ionic compound. All right, let's take a look at the next one. H2O, it's water. Let's see what type of bond it has. Don't overthink this. Some people see hydrogen to the left of the zigzag line and they're like, oh, it must be a metal. Use your common sense. Hydrogen is a gas. It is a non-metal. So because you have two non-metals together, surely water is definitely covalent.